So today in the lab we have something that's decidedly not retro, but still fairly interesting. Now this is a NanoKVM PCIe. It happens to be the PoE or Power over Ethernet variant. And I just got 4 of these a couple of days ago in the mail. And I paid for them with my own money. This is not sponsored, yada yada yada. But I thought they'd be interesting to feature on the channel. So you may be asking, what is this thing? Well, when you're administering servers, generally you want to be able to access them remotely and configure them remotely and things of that nature. Now, if we lived in a sane universe, most servers would have serial consoles like this SPARCstation 20 here, and we'd be able to run serial lines and access these machines from that and set early boot up settings and other stuff over the serial line and not have to have this other clunky bit of hardware. But we live in silly times where the dominant server architecture is derived from the original IBM PC, and we have to live with some limitations of that design. Most germane among them for this discussion is that an IBM PC assumes that there is a keyboard, mouse, and monitor connected to the machine. And if you want to get into, say, the early boot up settings or anything like that, the assumption is that you're physically at the machine. Now, modern IBM PC compatible servers like those from Lenovo and Dell and HP, they get around this by bundling as part of their server product something called an IPKVM, and there's various brand names for this. Dell has iDRAC, HP has iLO, I forget what Lenovo's is. But what these do is these give you a web interface that allows you to log into that web interface and manipulate the computer as if you're physically at it. And so it provides virtual keyboard, video, and mouse. That's what KVM stands for. Now, if you have a regular desktop PC, this is not normally part of the package. And so you have to add this in. And historically, there have been a variety of very expensive ways to add this in. But recently, people have been using these single board computers, like the Raspberry Pi, in order to provide low-cost IP-based KVMs for IBM PCs that don't have it. Now, the NanoKVM is not based off the Raspberry Pi. It's based off of a RISC-V microprocessor, but it offers a lot of the same functionality at an extremely low price point. I believe I paid $54 for this, maybe $55, and that is cheap. Traditionally, if you want to get an ISA or a PCI or PCIe card that did this, you're looking at hundreds of dollars. Now, to save everybody time, if you need something like this, I would say go get it. What you're seeing in this video is that this is very tricky to set up, but everything works, and man, for the price point, you can deal with all of those warts. However, if you want to see me struggle through getting this set up, watch the rest of the video and I have some final thoughts at the end. So let's get this unboxed. Right? I bought 4 of these and they come in 2 pieces. You have this nice little box here, and in it there's a piece of foam that houses the actual PCIe card. Let's take this guy out of here now. There's a hole right here for the Wi-Fi antenna. If you got the Wi-Fi version, which I did not, out-of-bounds management like this over Wi-Fi should scare you and would scare any competent security personnel. But the hole still remains. But that's okay. We can deal with that. There's a micro SD card already included that has the operating system that this thing runs. I believe that's the Power over Ethernet hat. In the box in the bottom compartment, let's open this up. So there's a low profile bracket, which if you're putting this into like a certain kind of chassis, this might be required. Let's see here the differences in the bracket size. USB cable, USB cable, and pin extenders. So this is what comes in the box. You got two USB-A to C cables, some pin extenders, an alternate bracket, and the card itself. Then these also shipped with a little bag of stuff that I guess didn't fit in the box. We have a very short HDMI cable and another set of connectors. So the idea here is that the computer's digital video output goes into this HDMI port, and then the USB goes into one of these two USB-C ports here, and that's how this card can control the computer. And then you plug this Ethernet jack into your network, and this will get an IP address. Now, my understanding is that the PCIe slot here is only used for power, but you can also power it via one of these USB ports or with power over Ethernet, which is what I'm intending to do. Now, unfortunately, this HP desktop that I was going to use as the guinea pig for this has a strange video connector on it. This is apparently a dual DVI connector that was popular back in the day, and so I'm going to have to order a cable adapter for this. So instead of the big HP tower, we're going to use this machine as our test bed here. This is a mini ITX PC that I built a long time ago, and I think I originally intended it as like a media server, but the board in it is now ancient, and I use it as a free IPA server, which for those that don't know, free IPA is, in a one-sentence summary, it's a Linux equivalent to Active Directory. The nice thing about this box is that it has HDMI, so no converter needed. And it'll also allow me to test a theory, which I think is going to be right, is that can I use this without a PCIe slot? So I think this only has PCI slots in it, but we'll see when we open it up. It's been so long I can't remember. Okay, I was correct. This just has a PCI slot in it. Now in future, I'm going to have this provided by my actual switches, but I haven't upgraded my switches yet, so I've got this injector which will inject the power over Ethernet voltages into the Ethernet cable without having to update my switches. So this is how I power it. Okay, let's get this set up. So HDMI. Now I've plugged in the Ethernet cable, which gives me power over Ethernet, and we can start to see something happening. And eventually, my camera may not be able to focus on this so tiny, but we get a little display. And this display is really hard for the camera to focus on. And it's also upside down at this viewpoint, but it has my Ethernet address and a few other things here. And so that's not the Ethernet address of the machine itself, that's the Ethernet address of this remote access console. And the Ethernet is over here connected to my power over Ethernet injector. And so I was right. The PCI connectors aren't needed. Now, this is useful in cases where you have a system where you have a bracket or a bracket position, but maybe there's no motherboard slot there. So you can place this where there's no motherboard slot in a vacant bracket and not use up one of your valuable PCIe slots, but you can power over Ethernet and still have it work. Now the PC isn't plugged on yet, so let's let's get this thing plugged in. Power into the PC itself. And then let's flip this guy on. Some of these cables take quite a bit of force to put in, so my keyboard wasn't working, or my virtual keyboard I should say, and it's because I hadn't gotten the USB-C cable all the way in. So basic keyboard and mouse seems to work okay. Now I want to go to the next level, which is power control. Now for this to work, you need a power supply with a soft power on, power off button, right? Which is basically means an ATX power supply or something similar. I'm dating myself by even introducing this caveat because that's basically almost every power supply sold for the last 10 years. But if you have an AT power supply, you're sadly out of luck. Now in order to do this, I'm going to have to disassemble this machine a little bit more to get at the correct pin headers. There they are, and kind of difficult here to see them. I'm going to have to figure out how to position this correctly in order to actually film this. Well, this might be the best that I can do. So on any modern PC, there's this pin header block here. These things control stuff, and this case is nice because it has it labeled. The power switch, HD, hard drive LED, power LED, things like that. So the idea here is that we're going to connect this pin header block up to the NanoKVM and then pass through those signals to the actual buttons on the case so that the buttons on the case and the LEDs on the case still work, but they can also be controlled and seen from the NanoKVM. So I got this completely set up, which means not just the USB and the video, but also all these little leads from the motherboard so that I can control power status and other things. Very fiddly to get correct. But essentially, there's a set of leads here that goes to the motherboard, and then you plug in the rest of the ones from your case. So like this is the power switch one in here. And that way you can control both the power status and get some other things from both the case buttons and also from the NanoKVM. So I can see whether the power LED is on or off. I can hit the power switch on and off from both the case and from the NanoKVM. This case doesn't have a reset switch. A lot of cases don't, but I can have a reset switch on the NanoKVM. There's also a pass-through for the disc lights, but that doesn't appear to be functional, and it's not in the source code for this unit, so maybe that doesn't work. I'm going to open up an issue on it. But this does work. Unfortunately, what I found is with this machine that I'm testing it on, which this machine right here is ancient. The last BIOS update for this thing was in 2012. Which means I think that I bought this in 2010, maybe? I don't know. I have to. So I mean that's almost 15 years ago now, and so I can see the operating system from the NanoKVM console, but I'm having trouble getting to the early boot up screen, and I think that it's an issue with this ancient hardware, not with the NanoKVM itself. So I've got this first test PC back together. Not really 100% success here. However, this wasn't the machine that I bought this for. This just happened to be the only one that I had with HDMI without a converter. Once I get those converters in from DisplayPort and DVI to HDMI, I should be able to test out the machines I actually want to use this with. Which are newer than this and more standard than this. This was like I say, almost a 15-year-old PC. The board in it is actually an industrial board. It's an Intel Atom. It's got some weirdness here. I don't know what I was going to expect, but we did learn some useful things here. First, on this board, We can power it exclusively with power over Ethernet, which is what I expected, but I had some friends of mine in various channels that I'm in ask that question. So we don't need to use the PCIe slot. Next, I figured out the wires situation. So we have two headers here that show the same thing, and it's maybe difficult to read. It says power, reset, HDD, power. So these are for all those leads on the motherboard. And so the cables like this, which came all connected and are just kind of, you peel them apart, this end goes to the NanoKVM, and then this end goes to the board. Very difficult to focus on these. So they would plug in here, and then the equivalent ones from the case would plug in on this block. So we got that figured out. Very finicky, but it works. Of course, this is a PC thing. It's always finicky with this. Always has been since the 386, 486 days. Now they also shipped to me this other kind of cable, right, which you can see has female ends on both ends. And I was kind of mystified about what to do with this. But what I figured out is this is actually meant to connect to the serial port. So if you have an internal serial port, you connect the receive and transmit lines here, and then there are headers on this board, and it's very difficult to see the writing here, but you have two UARTs here, so you can connect up to two serial lines and control them with the NanoKVM. Alright, so testing this on a more modern machine, I've got the NanoKVM hooked up to my DVI splitter here, because the video card in this uses an early combined port for dual monitors, right? Rather than having two connectors on the card, there's this DVI standard for a combined cable that then you have to buy a splitter for. I had VGA versions of this, but this does not work with VGA. This works with digital video signals, and fortunately DVI, HDMI, DisplayPort, it's all pretty easy to passively convert that from one to another. So I've got my DVI connection here to a DVI to HDMI converter, and then HDMI runs into the unit. And then also I've got the USB cord here. And this is a much newer machine than the original one I was experimenting with. This is an HP Z420, which is an odd name for a workstation if you think about it. Don't think about it too hard. But this was another thing that was given to me that I've kind of turned into a server here. And for this one, I can in fact get into the early BIOS menu and have it display on the NanoKVM. And that's the important thing that I wanted to see. And it seems to all work. I can go into all the menus. Everything that I've tried out, I can still see. Nothing blanks off the display. Let's now go a step further and try and install this unit as it was intended to in this HP machine. Well, for this HPE, I've run into a bit of a roadblock. This connector right here is for the power switch and the power LED and probably the hard drive LED too. And this board probably has a reset switch that's not exposed on the case. So I know which one of these connectors it is, but it's not standard, and it also does not appear to be labeled on the board. At least if it is, it's too tiny for me to read. So I'm going to have to trace this out and figure out what goes to what, and I don't have time for that at the moment. So we're going to try the other type of workstation that I wanted to put this in, which is a Lenovo branded workstation, and see if that goes any better. So next up, we're going to try out this ThinkServer machine here and see how it goes. Now fortunately, someone on the internet has already figured out where all the power and other pins are on the motherboard for this, so this one should go much easier. So from the case, we have an all-in-one connector here, and the pins don't match up with the pins on the NanoKVM, and it's not the same size. So unlike other cases where these are broken out by functions, this one just has one big one. And fortunately someone already did the work to tone out most of the leads on this so we know what they are. And so I was able to connect it all up, connecting this to the NanoKVM, and then the NanoKVM is connected to the board. And the problem is, we'll see if we can get a good shot in here, just it becomes a real rat's nest of wires. However, it does now work. I can power the machine on, the HD LED and the power LED pass through, and everything there looks to be good. So we'll load this into the actual case and continue on. Now the only lead that I did not connect was the reset lead, and I would like to have that functionality, and I'm almost positive on this board there is a reset. But for today, I'll tone that out later. I kind of want to get this one all back together so I can work on some other things today. And if I figure that out, I'll put a pinout in the comments below this video for both this machine and for the HP ones. So this is it all installed, and I can see why there are advantages and disadvantages to this. I have got 3 PCIe slots in here, both with different lanes, and this top slot here that I have this in is, I think, 16 wide, so it's meant for like a graphics board. The other ones are taken up with a dual Ethernet controller, actually maybe just a single Ethernet controller, and a PCIe to NVMe adapter. I'm all out of slots here. Now fortunately I'm using this as a back-end server, so it doesn't really matter. But if I wanted to add on to this, now this is taking up one of the slots. Now I do have a 4th slot in this machine, but since it's so ancient, this is a PCI slot, not PCIe, just PCI. And you know, maybe I could jigger something around, but it's full up now. So here we can see the whole thing now that it's installed, right? So I've got my Ethernet cord coming in to that. I then have a USB cord here, and then this is a display port. It comes out through this adapter and then back into the HDMI here. And one of the things that you can probably see, although it's very, very tiny, right, is that even though this PC is off, it is unplugged. I still have power to this device, and that's because this is power over Ethernet enabled. It's getting its power from the Ethernet cord. And the fact that this is powered in 2 places, from the Ethernet cord and then from the PC itself, doesn't seem to be an issue. Which you would expect. It's designed like this, but still sometimes you wonder. Alright, so now that I've got the NanoKVM installed and mostly functional, let's take a look at the UI that it presents. So I've navigated in my browser to the IP address of the NanoKVM, and I'm presented with this login screen, and I can log in with admin, which is the default username and password. And then it takes a minute to load here, but once it loads, we'll go through these different icons. So there's a bunch of different icons up here. There's a display icon which lets you set different video mode and other things around the video that it's capturing. With these more modern machines, I really haven't found a need to mess with this very much. There's a keyboard here where you can paste in arbitrary data as well as have an on-screen keyboard. There's mouse settings here, which, I don't know, I mostly use Linux on the command line, so this isn't that important to me, but it does work. There's the ability to mount images, so mount like a CD-ROM image to try and boot from it. I generally provision my machines over the network using Pixie Boot, so this is not so interesting to me. You can upload scripts, which I haven't experimented with, but presumably that can automate certain actions. And then you have a terminal here, which this is interesting, and I'll show this more later. You have the ability to send wake on LAN strings to arbitrary MAC addresses. And in this configuration with this PCIe where I'm wired into the power controls on the machine, I don't know where this could be useful. But if you're using this on some other kind of machine where you can hook up this device, but you can't connect the power controls, but for some reason it supports wake on LAN, well, this might be useful in that instance. Then we have a power button here, which if we click on that, we can see reset and power short click, power long click. And this button changes colors because I have the NanoKVM wired into the LED status, or the LED lines, I should say, for the power LED. This is actually reading and responding to what the status of the power LED is. Now there's a disk drive icon here. Unfortunately, this doesn't function, and if I update the software, it actually gets removed. I'm not sure if this is a not yet feature for the PCIe version of this, or if it's a not never feature for this. For this, we'll see. If it's not, it's no big deal, but it would be nice to have. Lastly, there's a settings menu where you can change some things, and then a full screen button and a little X to minimize the toolbar here. But you can get it back by clicking on the hamburger. So let's power this machine on. So now with this Lenovo machine, I know that this reset won't work because I don't have this wired up yet. I haven't found the reset lines. But the power lines I've got wired in. So if I do a power short click, that should bring on the machine. You can see the LED icon here change color to green, and we're starting to see output from the machine. And you can see all of these early boot up messages from the BIOS and from other things. This is what I want to see, because generally I want to be able to diagnose problems in the early boot up remotely, and this is going to allow me to do this. Now let's transition to the operating system boot. So it's running a version of RHEL here. And now that this is booted, you can see I can type and do various things. You know, just as if I were on the mouse, keyboard, and monitor directly attached to this machine. The virtual keyboard is nice because you know, sometimes it's nice to have a virtual keyboard, and sometimes with the browser interfaces, certain control keys get captured by the browser. So if I want to do like Control Alt Delete, I can do that from the virtual keyboard pretty easily. Now, and I can go into things like the BIOS here and do various different things. I've noticed on this release that some of these keys are being pressed twice. That might get fixed at a later release, so it's a little janky. This also might be fixable by changing the repeat setting somewhere in this BIOS, but we'll look at that later. But this BIOS for this IBM PC also supports the mouse, so you can see the mouse cursor moving around. It's a little laggy, but no more laggy than I've experienced on like a Dell KVM or a HP KVM, so this is well within norm for me. Now, if you were using this to try and like game on this PC, you know, this would be unacceptable, but for system administration stuff, this is just fine. Now, back in the operating system here, booted up Linux, and this is where this paste menu can come in handy. If I wanted to put in something like an SSH key or something like that, something long and that may not copy and paste correctly, I can do that with this menu, which is very handy. Let's talk about administering the NanoKVM itself. So all the software that runs on the NanoKVM is open source. There is a GitHub repository here that has all of the code for both the server and the web application. And all of this runs on top of a Linux core. And it appears to be some kind of BusyBox image. but you can access the actual Linux OS running on the NanoKVM by going to this terminal. So if you click here at this kind of terminal icon, you can go to this NanoKVM terminal, and it opens up a new window with a terminal, and now you're actually inside of the NanoKVM itself, right? So this is not the machine that we're using this as a KVM for. This is the actual operating system running on the NanoKVM. And it's a fairly standard Linux machine. I put my SSH key on here. You can SSH into it. There's not a lot of fit and finish on actually configuring this, but if you're comfortable with Linux, it should be no problem. So, like for example, I loaded in an SSH key here into my authorized key file. I'm not going to show that. But what that means is I can log in from just a terminal and access, again, the operating system of the NanoKVM from a terminal. And I can do things like set a static IP address, set up SSL, all that kind of stuff is possible, just so long as you know enough Linux to be able to do it. So whether this is an advantage or a disadvantage may depend on how comfortable you are with Linux administration. If you're super comfortable with Linux administration, this is great. This is, in my mind, a big plus that it's not some weird, non-standard custom configuration thing. It's just normal Linux stuff. I have had some trouble trying to set up SSL certificates and things like that, but I feel like those are bugs that will eventually get corrected in the upstream software. Now I did set a static IP address here, and because of that, right now I can't do the update from the utility here because I just set a static IP in a default gateway. It doesn't set a DNS server or anything like that. So if I were to set those here, and again, standard Linux, then I should be able to check for an update. Well, maybe not. But, it's not perfect. And so there are definitely some problems here. This product is definitely really cool but rough around the edges, and the administration kind of shows that. But still, this for the small amount of money, and see now it works. I don't know why. But let's update and see what happens. But like I was saying, for the small amount of money this is, I'm willing to live with a lot of warts around the edges on this. And the fact that it's open source means that I can go and fix these things myself if I want to. Now, another added benefit is all of this operating system stuff is stored on a SD card on the NanoKVM. And these are just standard Linux partitions. So if you really bork it up, and I did once, you can just take that SD card out and either flash it with a new version, or you can actually interrogate the file system and fix things. So I've done my update, and you can see now that the hard disk light is gone. Again, I'm going to open up a GitHub issue on that to get the final answer. Let's see if that update fixed my problem with the keyboard. Not quite. Now that I've been playing around with this thing for a few days, I have some thoughts that I want to close out the video with, and I guess you can consider this a review if you want. So first, let's start with the good. So first, the hardware quality is excellent. Really impressed with how this looks. Looks like a very professional product. Second, everything that I needed this to do when paired with the right kind of machine, worked. So, from a functionality perspective, it checks the box. Now, there's some bugs, there's some warts, but that leads me to the third point. The price point on this is hard to beat. At time of recording, it starts around 40 and goes to just under 60, depending on which options you have. Doesn't include shipping, but that's still a heck of a deal, and is the cheapest option for this on the market. And I feel like at that price point, I can tolerate all kinds of warts. That being said, there really weren't that many. I knew going into this that it needed to have digital video, that this wouldn't work with analog video like VGA. And so that first machine that I tested this on was so old that it was kind of on the boundary between VGA and newer standards taking hold. And so I don't think I can fault the board for the fact that my first test PC was weird. Once I got it with slightly more modern hardware, there was no issues with the video whatsoever. Now, setting up all the pin headers, that was really, really painful for the power, for the LED, for all of that. But this isn't the device's fault. This is really, IBM PC Compatible's fault. It's always been like that. It's been like that since, the XT days. So we can't really fault this device for that. But if you're planning on installing one of these, be prepared for that to be finicky, frustrating, and you might even cut yourself if your inside of your PC case doesn't have nice clean edges. So the next thing may be good or bad depending on your viewpoint. For me, it's a net plus, but I feel like you have to be pretty adept in your Linux skills in order to be able to administer this to the full capabilities that it offers. There's no custom configuration UI. It's all logging into the Linux operating system running on the NanoKVM and editing text files. To me, that's great. I hate a custom UI that does all kinds of wacky stuff. Just let me edit text files on a Linux partition. So this to me is a net plus. But for others, that may be a net negative, and it certainly is going to make it more difficult if you're not used to administering Linux. So last, and I think kind of most important, is that all the software that runs on this is now open source. And that means that this device will never become abandonware. So long as you have someone to update the source code, you can always get updates. And that you can know what this device is doing, because you can go look at the source code yourself. So I think that's really, really important. So final comments about this form factor. Right, the PCIe form factor is very nice. Makes it very neat and tidy just to have this inside of the case. I don't know if the power over Ethernet was necessary. However, it was less than a $10 upcharge, and it did prove useful during testing. Although I could have gotten that same functionality out of a external USB power supply. Now, there are other projects where I think the power over Ethernet would be useful, just not for these four that I'm putting this in first. Specifically, if I had a case where the motherboard was smaller than the case and there were empty card slots, I think that I would still mount this in there using one of the card slots, but since there would be nothing underneath it, I could power it via power over Ethernet. And that was my original thought. So we'll see if that may have some use for that configuration later. However, like I say, less than a $10 upcharge and doesn't hurt on these machines. So, it is what it is, and does not detract from my overall satisfaction with this device.